Lesson 5.7 is about subtracting linear expressions. Our objective is to learn how to subtract linear expressions. I want to go over something that we've talked about in class a bunch, but I want to reiterate it before we start this lesson. So, if I have an x, we know that there is a 1 in front of it. If I have a negative x, we know that that negative represents a negative 1 times x. So if I were to have an x look like this within parentheses with a negative outside, it would be just the same. It would be negative 1 times that x that's in parentheses. So that will apply for sure as we start 5.7. If you are still struggling on distributive property, stop, go watch distributive property video, which is 5.5, and then come back and watch this. Number 1, I have 6x plus 3 minus 2x plus 2. The first thing I'm going to do is add the opposite. Always, always, always go through and add the opposite no matter what type of problem it is. So I have 6x plus 3, and I'm just going to rewrite it down here, 6x plus 3, plus, now we just talked about that negative outside of parentheses means negative 1 times everything inside of that parentheses, 2x plus 2. So I use my distributive property. Remember, you have to give a cupcake to everybody inside. So you take 6x plus 3 plus negative 1 times 2x is negative 2x plus negative 1 times 2 is negative 2. Now, I'm going to write another step. I'm going to put it in red. I'm going to put it in green. I'm lying. This is not necessary. However, this step helps a lot of people. So I'm going to rewrite like terms by each other. So I'm going to do 6x plus negative 2x plus, my other like terms are 3 and negative 2, 3 and negative 2. Then I go through and I add the like terms. Now, the next step is necessary. So I do 6x plus negative 2x is 4x plus 3 plus negative 2 is 1. And the reason it's necessary is that's my answer. Circle it, and that's my answer. Number 2, I have 2x minus 3 minus x minus 2. So you guessed it, the first thing I'm going to do is add the opposite. So I'm going to go through. I always like to rewrite it with a negative 1 out front just to remind myself that that's there. So I do 2x plus negative 3. Again, this wouldn't be completely necessary. However, most of you will forget that there's a negative sign there if you don't rewrite it with a negative 1. So something to think about. Okay, then I use distributive property to distribute that negative 1 to everyone inside. So I have 2x plus negative 3 plus negative x, or you could write negative 1x. I'll write negative 1x, it might help some people, plus negative 1 times negative 2 is a positive 2 because a negative times a negative equals a positive. Man, chapter 3 haunts us everywhere we go, doesn't it? Okay, then I'm going to underline my like terms. So we have 2x and negative 1x. So 2x plus negative 1x plus, my other like terms would be negative 3 and 2. So 2x plus negative 1x is going to be a positive 1x plus negative 3 plus 2 is negative 1. I should have made that green, sorry. Now, a couple different ways that this problem could be written. This is perfect. I could also write x plus negative 1. I could also write x minus 1 because when I add the opposite, it would be the same thing. So, lots of different ways you can write it. All of them would be correct on a test. Number 3, a lot of times, number 3, my problem is negative 2x minus 4 minus 2x. A lot of times I have people that will see this negative sign right here, and they will think that means it's a subtraction, but there's no number in front of it, so it's not subtraction. What is it? it's a negative sign, just plain and simple a negative sign. So that's a negative 2x. Then I change all the subtraction to adding by adding the opposite. Then I have negative 2x plus negative 4 plus negative 1 times 2x. I use distributive, so that becomes negative 2x plus negative 4 plus negative 2x. I go through and underline my like terms of negative 2x, negative 2x. I'm going to write them next to each other just to make it easier to see. And then plus negative 4. Negative 2x plus negative 2x is negative 4x plus negative 4. And I circle it, and that's my answer. Again, you could also write this as negative 4x minus 4, and that would be just as much the correct answer. So if you want to laugh in the middle of this, I just started talking to myself and I hadn't hit record, so that's embarrassing. So number 4, I have 6x plus 5 minus 3x plus 1. So I'm going to add the opposite. I'm going to rewrite it as 6x plus 5 plus a negative 1 times everything inside 3x plus 1. I'm going to distribute my negative 1, so I'm going to have 6x plus 5 plus a negative 3x plus negative 1. Then I'm going to go through and I'm going to underline my like terms. So I have 6x, negative 3x. Let's rewrite those next to each other so it's clear to see. Plus, then I have 5 and negative 1. And I go through and I do my math. 6x plus negative 3x is 3x. Plus 5 plus negative 1 is 4. So I have 3x plus 4 is my final answer. Okay, number 5, I have negative 4x minus 7 minus negative 5x minus 2. Lots of negatives and minuses here. So I'm going to add the opposite. That becomes negative 7. Add the opposite. We have a negative 1 outside now. Add the opposite. Now that's a negative 2. So I have negative 4x plus negative 7 plus negative 1 times negative 5x plus negative 2. I'm going to use distributive property, and we have negative 4x plus negative 7 plus negative 1 times negative 5x is a positive 5x, because a negative times a negative equals a positive, plus negative 1 times negative 2 is a positive 2, because a negative times a negative equals a positive. Then we go through and we underline our like terms. So we have negative 4x plus 5x, negative 4x plus 5x, plus negative 7 plus 2, negative 4x plus 5x is going to be a positive 1x, and negative 7 plus 2 is going to be negative 5. I'm going to circle it, and that's my answer. Number 6, a hat store tracks the sale of college and professional team hats for M months. The number of college hats sold is represented by 6M plus 3. The number of professional hats sold is represented by 5M minus 2. Write an expression to show how many more college hats were sold than professional hats. Then evaluate the expression if M equals 10. Okay, this problem tricks people up pretty bad. So, first thing I'm going to do is explain it to you. If you're struggling with this type of word problem, the first thing I would do is I'd go through and I'd reread it as if it was just a number. So I might say, the number of college hats sold is represented by 6. The number of professional hats sold is represented by 5. Write an expression to show how many more college hats were sold than professional hats. So that is something that you learned how to do when you were, I don't even know what grade, so I'm not going to even pretend. But you would take college hats. It says how many more college hats. So we know college hats is bigger minus professional, right? Well, we're going to do that. We're just going to do it with a lot of other things involved. So we're going to take the college hats was 6M plus 3. minus the professional has. So there were more college than professional, which is funny to me. I feel like it would be the opposite, but I don't know. Okay, then you go through and add the opposite. And you have 6m plus 3. I'm not going to rewrite it this time. I'm going to just distribute that negative. So I'm going to have negative 5m plus a negative times a negative equals a positive 2. And then I have my like terms, which are 6m and negative 5m, which is 1m or m. And then my other like terms, which is 3 and 2, and that's plus 5. So that is a part of your answer. That is like on your test, that's 1 point of your answer. Then it says, now evaluate the expression if m equals 10. So we plug in 10. So we do 10 plus 5 is 15. And I circle my answer. Now, I have had kids that have trouble with the algebraic expression. So what they do is they go through and they fill in 10 for these m's, find the answer, and then work it backwards to make sure they got it right, and that's totally okay.